In this session, we shall look at another concept from geometry. We shall look at quadrilaterals and polygons. Now, a polygon is a closed figure in a plane, and it is basically distinguished based on the number of sides the polygon has. If it has 4 sides, it is called quadrilateral. We have quite a few 4-sided polygons. For example, square is a quadrilateral, rectangle is a quadrilateral, a rhombus, a trapezium, a parallelogram, a kite, all these are special types of quadrilaterals. If you have 5 sides, we call it a pentagon. If you have 6 sides, we call it a hexagon. If you call 7 sides, we call it a heptagon. If you have 8 sides, we call it an octagon, and so on. Some typical properties that is common to all polygons. In a polygon, look at this figure. This angle is called the internal angle. This angle is called the external angle. This is the external angle, and this is the internal angle. The sum of the internal angle and the external angle will always be 180 because it is essentially a straight line. Now, if you add all the external angles of a polygon, be it a quadrilateral, a pentagon, a hexagon, anything, you will get it as 360. Because if you go from here to here, here, this way, and this way, you are basically traversing a full circle, which is 360 degrees. So sum of all the external angles will be 360. And consequently, the sum of all the internal angles of a polygon will be n minus 2 into 180 degrees, where n is the number of sides. For example, if you have a quadrilateral which has 4 sides, the sum of the internal angles will be 4 minus 2 multiplied by 180. That is, sum of the internal angles in the case of a quadrilateral will be 360 degrees. In the case of a pentagon, n becomes 5. So 5 minus 2, 3 multiplied by 180. The sum of the internal angles will be 3 into 180, which is 540. In the case of a hexagon, where we have 6 sides, n becomes 6. So 6 minus 2, 4 into 180, this will be 720 degrees. The sum of the internal angles will be 4 into 180, which is 720, and so on. Now, as I said, we have quadrilaterals, pentagons, hexagons, heptagons, etc. Now, if in a quadrilateral or a polygon, if all the sides are equal, we call it as a regular polygon. In a regular polygon, the area of a regular polygon is given by half into perimeter into the length of the altitude drawn from the center to any side. What we are basically doing is we are basically splitting this into small triangles and finding out the area of each triangle and adding it up. So it will be half into perimeter of this polygon into altitude drawn from the center to this side. Now let us focus our attention on a few quadrilaterals. As I said, a quadrilateral is a 4-sided figure. We have quite a few quadrilaterals which are very common, and those quadrilaterals come very often in aptitude test paper as part of questions. The most common quadrilateral that all of you are familiar will be the square. What is the peculiarity of a square? In a square, all the 4 sides are equal. All 4 sides are equal. The angle between adjacent sides is 90 degrees. Opposite sides are parallel. The diagonals, the square has 2 diagonals. The diagonals intersect at an angle equal to 90 degrees. These are some properties of a square. If you want to find area of a square, all of you know that area of a square will be given by square of the sides. How do you find perimeter of a square? There are 4 sides. Each of them is the same. So a plus a plus a plus a plus a will be 4a. Perimeter will be 4a. Now compare this with the second most familiar figure, the rectangle. How is a rectangle different from a square? In a square, all the 4 sides were equal, but in a rectangle, that is not the case. Opposite sides are equal. If I take this as length and this as breadth, we have the 2 opposite sides equal. These 2 opposite sides are equal. The angle between the adjacent sides is 90 degrees. The diagonals bisect each other. Bisect means it cuts into 2 equal parts, but they are not perpendicular bisectors as in a square. In a square it is a perpendicular bisector, whereas in a rectangle it will not be a perpendicular bisector. If you want to find area of a rectangle, what we do is we find area as length into breadth. Perimeter will be sum of the lengths and breadth, L plus B 2 times length plus breadth. Another commonly seen quadrilateral is the rhombus. Rhombus is mostly a skewed square. You tilt the square a little, you get a rhombus. All the 4 sides are equal, but the adjacent sides are not perpendicular. The angle between the adjacent sides will not be 90. Here it will be less than 90, here it will be more than 90. Okay. But this angle and this angle will be the same, this angle and this angle will be the same. The diagonals will bisect each other. If you want to find the area of a rhombus, it will be half into d1 into d2, where d1 and d2 are the diagonals. Perimeter will be 4 times a, because all sides are equal. The next common quadrilateral is the parallelogram. If you tilt the rectangle, you get the parallelogram. In a parallelogram, the opposite sides are equal, but the adjacent sides are not perpendicular. This angle will not be 90, this angle also will not be 90. These 2 angles will be same, the opposite angles will be the same. Okay. The diagonals will bisect, but they will not be perpendicular bisector. The area of a parallelogram is given by area equal to base into height, where this will be the base, the height will be the altitude. Okay. Now that we are familiar with these quadrilaterals, let us do a couple of problems. Let's say you have a rhombus. Of side 10 centimeters. The rhombus is named A, B, C, D. It is given that BD is 12. BD is 12. Can you find the area of the rhombus? BD is 12. Now when we discussed the properties of a rhombus, we saw that the rhombus has the diagonals bisecting each other at 90 degrees. The diagonals will be perpendicular bisectors. That means BD is bisected at this point. This will be this length, let me call it BP. BP will be 6. So will be DP. BP and DP both will be 6. This angle is 90 degrees. We know this side as 10. Observe this. The triangle CPD will be a right angle triangle at P. We know the hypotenuse. We know this side. So we can find this side. What will be the value of that? Applying Pythagoras theorem, we can say it will be 10 square hypotenuse square minus 6 square, that is the base square root of that will give you the altitude. So this will be 100 minus 36, square root of 64, which is 8. So this side is 8. Now we can find the area of the triangle CPD. What is the area? It is half into base into height. Half into 6 into 8. Which is 24. All these triangles, let me call it as M, N, O, and P. All these triangles are identical. So once you find the area of one triangle, it is a matter of multiplying that with 4. So the area will be 24 into 4, which is 96. Total area will be 96 centimeters square. Let's look at one more problem. Let us say you have a regular hexagon. What do you mean by a regular hexagon? A hexagon has 6 sides. A regular hexagon is a hexagon where all the 6 sides are equal. Let's say the regular hexagon has side 10 centimeters. What is the area of this regular hexagon? That is the question. You are asked to find the area and perimeter of this regular hexagon. Finding out perimeter is straightforward, very easy, because we have 6 sides. Each of them has a length 6 centimeters. 6 into 10, sorry, each side will be length 10 centimeter. So 6 into 10, we have perimeter as 60. What about area? Let us look at this. We have a regular hexagon here. Regular means all sides are equal. Each side is 10. It is very symmetric. Let us draw the diagonals. Let me name this as A, B, C, D, E, F, and let me call the center point as P. We saw that in a regular hexagon, the sum of the internal angles, that is this angle plus angle B plus angle C, D, E, F, and A, all of them added together will be n minus 2 into 180. What is n here? N is 4, so 4 minus n is 6. So 6 minus 2, 4 into 180, which is 720 degrees. The sum of all the internal angles will be 720. All the angles are identical because it is a regular hexagon. So 720 has to be divided into 6 equal parts. 720 divided by 6, you will get it as 120 degrees. So angle B, angle A, all of them will be 120. And this diagonal AD bisects the angle A. That means the angle TAF will be 60 degrees. This will be 60 degrees. Similarly, angle PFA will also be 60 degrees. So this is also 60. Now if these two angles are 60, the angle APF will naturally be 60 because the sum of the three angles should be equal to 180. So all the three angles in this triangle are equal, they are equal to 60 degree. That means the triangle APF is an equilateral triangle. And we know how to find the area of an equilateral triangle. Area of an equilateral triangle is given by root 3 by 4 a square, where a is the length of one side. We know the length of one side as 10 centimeters. So area of one of these triangles, any one of those triangles, will be root 3 by 4 into 10 square. That is 100 by 4, 25. 25 root 3 will be the area of one triangle. Now if you look at the entire regular hexagon, we have 6 such triangles. So total area will be 6 into this, 6 multiplied by this, so it will be 150 root 3. So the area of this regular hexagon will be 150 root 3. So we shall stop this discussion with this problem. In this discussion we saw a few aspects of quadrilateral and polygon, compared a few quadrilaterals, and we looked at a couple of problems. Thank you.